Hello friends, this is our lecture number 6 in nanoscience, and today we will discuss the classification of nanomaterials, and the topics we cover will be classification of nanostructure materials based on the dimensions, Gleiter classification, and we also discuss the graphene, Fullerene, and then a scheme which is known as kDlmn scheme of classification for nanomaterials. So nanomaterials are classified on the basis of their origin, dimensionality, morphology, composition, uniformity, physical properties and agglomeration. But here we will discuss just dimensional basis and on composition basis. And based on the dimensionality, nanomaterials can be classified in 0 dimension, 1 dimension, 2 dimension and 3 dimension. By origin, we can classify the nanoparticles in natural nanoparticles, and they are made by nature, like volcanic ash, forest fire, pollution, dust particles. These all are natural nanoparticles. Also, in biological objects like in butterfly wings and lizard legs, they have some nanostructures and nanoparticles by biological species. These are all natural nanoparticles, and the artificial nanoparticles are made by uh, artificially. These are made by top down or bottom up approach or chemical or physical techniques, and they may be metal nanoparticles or semiconductor nanoparticles known as quantum dots, carbon based nanoparticles or composites. So these all are the classified by origin. So based on the dimension of the material, they are classified in 0 dimension, 1 dimension, 2 dimension and 3 dimension. And in 0 dimension, all the dimensions x, y, z are at nanoscale, and these should be less than the diameter, or the dimension should be less than 100 nanometer. Then this type of materials are known as 0 dimension material, and electrons are confined not to move in any direction, just it is like a dot. And in 1 dimension, we have the 2 dimensions are at nanoscale, and 1 dimension this length is not. So these are known as the 1 dimension material, and electron can move freely in one direction. In 2 dimension case, we have only, this is the like layer structure, only thickness is in nanometer range, d is less than 100 nanometer, and other 2 dimension lx and ly, they are not in nanometer range, and electron are free to move in these two directions. And 3 dimension material means none of the dimension is at nanoscale, and electron can move freely in this 3D structure. So 3D dimension nanomaterials, they are made from these 0, 1 or 2 dimension materials, nanomaterials. So 0 dimension nanomaterials are those materials, they have all the 3 dimensions negligibly small, means they are in nanometer range, and they are also known as artificial atoms or quantum dot because their energy levels are discrete. So we will discuss it later, that the energy levels of 0 dimension nanomaterials are discrete. And metallic nanoparticle like gold or silver, or some semiconductor nanoparticles like cadmium sulfide or these cadmium selenide, these are quantum dots. They are 0 dimensions. Also the nanoparticles, they may have any kind of shape, spherical, cubic or any polygon shape, and they should have the size in the range 1 to 100 nanometer. And most common example is fullerene, which is also made of carbon, and this structure was identified by Proto and co-workers. And 0 dimension means where all this, like we can say that it is a small dot or any such kind of shape which have very small dimension in all the 3 dimensions. Fullerene is one of the carbon, this nano material, and the shape is like soccer ball. So carbon atoms are arranged like this, and these are also some nanoparticles. So these all are zero dimension nanomaterials. In one dimension nanomaterials, they have two dimension of particles in nanometer range, and the third dimension is very small. So it is one dimension in nano. Then we can say that they have the length of greater than 100 nanometer and diameter of very few nanometers, less than 100 nanometer. These are nanotubes, nanofibers, nanorods, and carbon nanotube, nanofibers. These all are examples of one-dimension nanomaterials, like carbon nanotubes and other nanotubes are there. So they have the length, but the diameter is very small in nanometer range. These are one dimension, all the whiskers and these tubes, these are in nanometer, one dimension nanomaterial. In two dimension nanomaterials, we have layers, and they have only one dimension in the nanometer scale, and other two dimensions are large enough uh, to as compared to third dimension, like graphene nanolayers. Graphene is a layer of carbon atoms, nanosheets, nanofilms, and platelet-like structures. So these all are two-dimension nanomaterials, and nanofilms or coatings in the order of several square centimeters, but their thickness would be in the range of 1 to 100 nanometers. So their other dimension, two dimension may be larger. So they are the layer structure, and one of the dimension is in nanometer range. So these are known as two-dimension nanomaterials. They may be different kind of layers. And three-dimension nanomaterial means basically these are the nanostructured bulk materials which are made for some, suppose they are made from nanoparticles with mixed with some composite, or they are some nano layer in between. So these are the combination of some 0, 1 or 2 dimension materials to make this 3-dimension structure. So these are the bulk materials. So all the dimensions are greater than 100 nanometer, but some of the components making this structure, they are nanomaterials. So it is nanowires, nanotubes, or multi-nano layers, and they are, if they are mixed within some matrix or some polymer, then we can say these are 3-dimension nanomaterials. Now the classification of nanomaterials based on the type of material or composition. So these may be carbon-based materials, metal or metal oxide-based, dendrimers or polymer-based, and composites or the mixture-based materials. So carbon-based materials are basically composed of carbon in different shapes or different form. Suppose if they are making some hollow sphere, then it is fullerene. It is zero-dimension material known as C60. One dimension case, these are carbon nanotubes or carbon fibers or some kind of nanorods. In two dimension, these makes the layer structure such as graphene, and three dimension case, they are the such as carbon as graphite or diamond, etc. And we can see in zero dimension case, it is the Fullerene structure. In one dimension, these are carbon nanotubes and nanorods may be also there. Two dimension case, it is the layer of carbon. This is known as the graphene. And in three dimension form, the example is graphite powder or some diamond, and these are the three-dimensional structures. These carbon-based materials have several applications, and according to their arrangements, we can see fullerene has this kind of structure, that hollow sphere, and this kind of tube-like structure, it is known as carbon nanotube. Graphite and graphene have some carbon uh, atoms, they are in like a sheet arrangement, or and graphene oxide, carbon. These all are the how the carbon is arranged to make these kind of nanostructures, and they have many applications in different coatings, and they used to make to give the some strength to another materials, and they have applications in electronics and other devices also. Graphene is hexagon shaped plain carbon atoms in a sheet form. It is like this hexagon, or it is single layer of carbon. carbon monolayer is there, and it is allotrope of carbon in form of a plain sheet. Now, carbon-based fullerene, and also known as the buckyballs, and these are the hollow cages with very high electrical conductivity, and these are named after Buckminster Fuller, who designed such kind of dome-like structures with so matching with this Fullerene structure. So that's why it is named as buckyball. And it have this is carbon 60 and carbon 70. They are the like Fullerene structure. Metal-based materials means they have either they are the gold or silver or platinum. These are the uh, quantum. These are the metal oxide nanoparticle, and also quantum dots like some semiconductor particles, or zinc oxide or titanium oxide nanoparticles. And quantum dot is semiconductor crystal nanoparticles, and they have the sizes of few nanometer to few hundred nanometers. Like, so this is gold nanoparticle, and the silicon oxide coating is on that. We can see the image also. This is the TEM image, where we can see in the core the gold nanoparticle is there, and outside there is silicon oxide is there, and in between some organic compound citrate is there. Metal nanoparticles may be gold, selenium, titanium oxide, or zinc oxide. These all are based from the metal nanoparticles, and for different applications they are used. Suppose iron nanoparticles, they are used as anti-cancer therapy, and zinc oxide are used in the cosmetics or some powders, and the gold nanoparticles, they are for biosensors, drug delivery. So different applications of these metal and their oxide nanoparticles are in our daily life. Then dimers are the branched molecules are arranged in such and this type of structure, and it is originated from the Greek word dendron, means tree like structure, and they are basically nanosized polymers, and they make some kind of branches, and there are different chains and which have different chemical functions, and they are used for molecular recognition, nanosensors, and in also optoelectrochemical devices, and also used for drug delivery also. So composites are the combination of nanoparticles with another nanoparticles or with some bulk type of material, and they are used to make different products like auto parts, packaging materials, and also in our daily life there are a lot of composites where these nanoparticles are used, and they can improve the mechanical, thermal, and another properties. And nanocomposites may be polymer based, means the ceramic nanoparticles or inorganic nanoparticles, these are mixed with some polymer, and then the polymer and these particles will make some structure, composite structure. And there may be non-polymer based, means metal nanocomposites, two nanoparticles or two nanolayers of metal, or ceramic nanocomposite or ceramic nanocomposites are there, which are non-polymer based. Now we will discuss the Gleiter classification, and as we know that um, solid materials are made from the grains, and these grains are separated by some grain boundaries. So we have the grains and grain boundaries. So using these structures, Gleiter have classified the nanostructure materials in 1995, and it was further extended by other scientists in 2005, like those were Pevney and Scoroford. So it was extended later. So basically, Gleiter have classified according to their composition and the arrangement. They were classified in 12 classes, and based on intercrystalline grain boundaries and crystallite were considered as the building blocks. And here we will see in next slide that there are 3 classes and 4 types, which makes 12 classes. But at that time, these graphene and fullerene was not known, so that's why it was added later. So it was based on uh, Glitter classification is based on the chemical composition and the shape of the crystallites and their arrangements. We can see there are 12 classes or 12 kind of arrangements are there. So they may be layered structure and some rod type structure and some equiaxed crystallites. So depending on their axis, they are arranged like this. These are known as equiaxed crystallites. So there are 3 combinations with layer, rod, and equiaxed, and depending on their chemical composition. If the chemical composition is same, then or they may be different, and composition of boundaries and crystallites are different, and crystallite disperse in another kind of composition, then this is the 4th combination. So suppose we have layered structure which have the same uh, chemical composition. So one layer is this, another layer is in another direction, but the chemical composition is same. Here the layer are we have again the layer structure, but here the composition of the crystallites are different. Suppose this is one composition, this is second composition. So this in this case we have composition of the boundaries and the crystallites are different. So crystallites we can see this structure, and boundaries we can see the separate structures. And in some cases the crystallites are dispersed in some matrix, like some polymer or some another kind of matrix. These crystallites are dispersed. So these are 4 combinations. Similarly, in the case of rod also, same material is there. Here, the rods, but their structure we can see from these grains that their structure is different. Here, the composition, the rods have another structure as grain boundaries. These boundaries are different, and here these rods are dispersed in some another kind of matrix. So again, these are, and in case of this kind of structure, again the crystallites of the same material. Here it may be different material, and boundaries are different as compared to the grains, and also these type of grains are dispersed in polymers. So these all combination make 12 classes, and this was the classification given by Gleiter in 1995. Later, when after the discovery of the fullerene and graphene, now there are 36 classes. We will see in next slide. So on different combination, they Gleiter have classified in 12 classes of building blocks, but fullerene and graphene structure was not known in that time. So later those were also included, and a new scheme which is known as the kDlmn scheme was used for the classification of nanomaterials, and now it includes the fullerene and these 0 dimension, 1 dimension, all kind of combinations are there. And this kDlmn combination will make 36 combination depending on their building blocks. So we will see how these we classify the kDlmn scheme for the classification of nanomaterials. So this K is the dimension of the nanostructure as a whole. Suppose we are talking about the 1 dimension, so it will be 1D. For 2 dimension it will be 2D. 3 dimension it will be 3D. Capital D shows the dimensionality, and this K will tell that it is 1, 2, 3 dimension. And L, M, N, these are the building blocks, means using 0 dimension, 1 dimension, 2 dimension, we can make 0, 1, 2, 3 dimension materials. And this k should be greater than or equal to L, M and N, and they all should be integer. And now we will see how it is used for classification. And because there are three elementary units, 0 dimension, 1 dimension and 2 dimension, because 3 dimension is not included because it is not a elementary 3 dimension nanostructure is not there. It is made of these structure 0, 1, 2. So these are the elementary unit. And then kDl type, it will make 9 classes in which one unit is there, L. And if we use LM 2 units, then it will make again 19 classes. And if we use all the combinations, uh, then we will have 3 plus 9 plus 19 plus 5, 36 classes. We will see the image in next slide. And this K, D, L, M and K is the dimension of the total nanostructure. L, M, N, these are the elementary units. And we have already discussed that this K should be greater than or equal to L, M, N. And this will make total 36 combinations. Here we will see that how these 36 structures are made. So as we know that K should be greater than or equal to L, M, N, and three basic units are there. 0 dimension means some nanoparticles, molecule, cluster, Fullerene. These are the 0 dimension material. 2 dimension maybe nanotubes, nanofibers, or some spirals of some length. So this is 1 dimension material. In 2 dimension, these are the nano layers. So these are the three basic units. Three combinations are there. To make the 0 dimension, we have two combinations. 0 dimension material can be made from the 0 dimension material, and using two types of 0 dimension material. So two part nanoparticles will make another nanoparticles or 0 dimension. So there are two combinations. In 1 dimension structures, it can be have 5 type of combination, because 1 dimension material can be made from 0 and 1. So there it either, if we are making only from 0 dimension material or nanoparticles, some chain is there, so it will make 1 dimension material using 0 dimension material. Similarly, we can take 2 0 dimension material to make the 1 dimension structure. So one is this and another is this, so we can make a chain or heteropolymer. Similarly, 1 dimension material can be made one uh, 1 dimension material, and 1 dimension material can be using one dimension, so it may be some hetero kind of structure. And 1 dimension material can be also made from 1 dimension and 0 dimension materials. So there are 5 combinations. And 2 dimension nanostructures can be made from only 0 dimension material, like Fullerene particles can be used as to make the layers. So 2 dimension structures means some layers or some films. So we can have some combination from 0 dimension or 1 dimension material and even 2 dimension material. So this all combination will give us 10 combination for 2 dimension structures made from the basic units. In three dimension nanostructures, we will see there are 16 type of 3D combination using the LMN building basic building blocks. So LMN can be 0, 1, 2, and 3 also in this case, because we are making the 3 dimension. So K can be greater than or equal to this LMN. So here we have the combination from 0, 1, 2, and then 3 dimension can be made from 0, 0, 1, 0, 1, 1. So suppose 3D is made from zero dimension, or some fluorine nanoparticles are made used to make this three-dimension structure. Similarly, three-dimension structure can be made from the nanofibers or nanotubes. So this is how one-dimension material is used for making three-dimension. Similarly, two-dimension, 3D2 means three-dimension structure is made from the two-dimension unit. That is the two-dimension unit was some layers. So layers are arranged to make this three-dimension structure. 3D00 means two type of zero-dimension material are used to make this three-dimension material. 3D10 means we have used one zero dimension means some dot, and one dimension means some layer or rods to make this three-dimension structure. 3D11 means we have layers. One dimension means some nanorods or nanofibers. These are made of two types of nanorods are used to make this three-dimension skeleton or structure. Three-dimension material can be also made from two dimension and zero dimension. Two dimension means it is layer, and zero dimension means some particles. So this three-dimension structure is made from the layer, that is two dimension. Zero dimension means some particles. So this kind of skeleton is known as 3D20. 3D21 means 3D structure is made from two dimension and one dimension structure. Two dimension means some layers, one dimension means some rods or uh, nanofibers to make this kind of structure. So we can see that there are different combinations, 3D22, 3D30, and all the combinations. Finally, we will have combination of one dimension, two dimension, and three dimension to make this three-dimension material. So these all will make 16 type of combinations, and if you add these all type of combinations, there are 36 combinations, and these 36 combinations are in allowed in this kDlmn scheme. So we have seen the classification of nanomaterials based on their dimensionality, that was 0, 1, 2, and 3 dimension. Then we have discussed the Gleiter classification. In that case, 12, uh, 12 classes were there. And here in this kDlmn scheme, we have 36 combinations. So thanks for watching this video. And if you have any queries or suggestion, then please write in the comment box. And last video, we have discussed atomic packing in crystals. And in next video, we will discuss the quantum size effects and the basic quantum mechanics required for the nanotechnology. And if you are new to this channel, then please subscribe. Thank you.